Today's lesson is on interpreting linear graphs. This will cover pages 88 to 89. So we'll be reviewing that linear graphs are graphs that all the dots that you plot or the points that you plot can be connected by a straight line or a ruler. For question 1, you will be given several graphs on the same grid paper, and you'll be asked to make a t-table for each set of points. So I'm just going to do 2, whereas you will have 3. So you have to look at what they're labeled. So this one is labeled A and this one is labeled B. So we're going to start with A. So we look at our first point and go, okay, what is our input and what is our output? So remember, our input always goes along the bottom. So I'll even label that to help me remember. And output goes up the sides because we always look at X and then Y when we're making our t-table. So whatever's in the first column will be our X value. So as we look at this, our input is 1 and our output is 1. So we will write 1 and 1. Then we look at our next point. Our input is 2 and our output is 3. So we'll write 2 and 3. Our input, if we go down, is 3 and our output is 5. So we have 3 and 5. And our fourth point, it's kind of hidden behind the yellow one, but it matches up with our input of 4 and our output of 7. So we would write 4 and 7. For our second graph, B, once again, we'll start at the first point. So our input is 1 and our output is 4. So 1 and 4. Then we look at our next point. Our input is 3 and our output is 6. So you'd say 3 and 6. Then we'd have our input is 5 and our output is 8. So we'd put 5 and then 8. And finally, our last point, our input is 7 and our output is 10. So we would have 7 and 10. So that takes care of part A. For part B, they're going to ask us to write a rule for each t-table. So when we're writing our rules, so remember, a rule is going to have words instead of a formula. So it will be like a start at blank and then add or subtract. And in this case, we're always going up. So we'd add something each time. This will be our format for writing our rules. Now to do this, we're actually just going to look at the output values because our input's going up by 1 each time for this one. So we're starting at 1 and then we are adding 2 each time to get to the next number. So start at 1, add 2 each time. Now our second one is a little bit trickier because you might think that your rule would be start at 4 and add 2 each time. But the thing is, our input is not going up by 1, it's going up by 2. So this is actually wrong. Instead, what we'll notice is that there's almost an invisible extra dot in the middle, right? So we could actually say that there's a point in between here that's 2 and 5. If I show my pointer, it lines up with 2 and 5. And if I look in between here, it actually lines up with 4 and 7. So it's almost like I could put 4 and 7 in here. And if I looked at a dot here, well, that's 6 and 9. Really, if you included all the numbers in between, each time you're not adding 2, you're actually only adding 1. So the rule for this one would actually be start at 4 and add 1 each time. So don't be tricked if they're skipping ones, but there are points in between. Question 2 asks you to make a third grid point and write the ordered pairs. So as we're looking at our graph, here's our first grid point, here's our second. Our third would be the next point that it actually touches two corners on the grid. So we could add our third dot here, and then our job is to write ordered pairs. So we're always going to go first number and then second number. So if we look at our first point, it is 1 and 2. Remember, we always go down to the x-axis or the first number first. So it would be 1, 2. Our second point, start down, so it goes to 2 and 4. So that would be 2, 4. And our third number that we have made, our third point, is lining up with 3 and 6. And make sure you keep this order of x or first number and then y or second number. Question number 3, you guys are actually on your own because they're getting you to make your own graph and your own t-table. So they have the framework there for you, so you need to make sure that you are plotting at least 4 points and that they are all in a straight line. So you should be able to connect them with a ruler, and then you go and you plot your points. So your first number's on the x-axis, your second number's on the y-axis, and they have those labeled for you. For questions 4 to 7, you're basically answering a bunch of word problems and making graphs to interpret what they're saying to get answers. So I'm just going to briefly go through what they're saying and offer some suggestions, but you'll be finding all those answers on your own. So the first one says the graph shows the cost of making a telephone call to New York. So they've got their length or their minutes that the call takes on the bottom and the cost in cents on the y-axis. So if you talked for 2 minutes, how much would you have to pay? So you need to look at where is 2 minutes and then see where that line matches to cost. How much does the cost rise every minute? So you just need to go, okay, here's 1 minute. This is how much it rises. Here's the second minute. Here's how much it rises. How much would you have to pay to talk for 10 minutes? So they only go to 4 minutes here, but if you figure out your rule, then you would be able to figure out for 10 minutes. You might also decide that you want to make a t-table and extend it to 10 minutes. For D, if you paid 6 cents, how long would you be able to talk for? So this time you're going to start on the cent side and go, okay, if I paid 6 cents, that's how long I could talk for. How much would you have to pay to talk for 30 seconds? So 30 seconds is going to be halfway between 0 and 1. So if 1 minute is 2 cents, how much is 30 seconds? Number 5 is talking about Kathy going on a cycling trip. So one of the things you might notice is it kind of plateaus here. So we've got the time and we've got the distance. So she's traveling and then all of a sudden the distance stops, but time keeps going. So what can we assume? Well, she probably stopped biking at this point. So if we look at how far had she cycled after 2 hours, so we look at our 2 hours and see what matches. How far had Kathy traveled after 6 hours? Well, here's our 6 hours. See what matches. Did Kathy rest at all? Well, that's kind of what we were saying at the beginning, right? This is what this probably means. Time kept going, but she did not. Also known as a rest. And when she was cycling, did Kathy always travel at the same speed? So if we look here at this section, is it going up by the same amount that it is for the last bit of her trip? Question 6 has 2 graphs. One is for Ben and one is for Tom, and they're both racing in a 120-meter race. So we have Tom and we have Ben. So the time is on the bottom in seconds, and the distance from the starting line in meters is here. So How far from the start was Tom after 10 seconds? So you can look at Tom after 10 seconds, how far is he? How far from the start was Ben after 15 seconds? So 15 seconds, you have to make sure you look at Ben's time, or Ben's graph. Who won the race and by how much? So you can look at who got to the 120 meters faster. How much of a head start did Ben have? So you may notice that Ben, his line doesn't start at 0, it starts at 40. So you'll need to figure out when did he actually start. So if you were to make a t-table and you know how much he goes up by, you can figure out how much he goes down by and about how far ahead he would have had to start, right? So if we're looking at every 20 meters is about 15 seconds for him. So then you'd have 15 seconds here and 15 seconds here. And how many seconds from the start did Tom overtake Ben? So when they started, how long did it take Tom to get to the same place as Ben and then go past him? The graph shows the cost of renting a bike from Mike's store. So how much would you have to pay to rent a bike for 2 hours, for 4 hours, or for 3 hours? So our 3 hours doesn't match up with a point, so you might have to figure out how much is it going up by overall to get from here to here, and then half of that distance would be what it goes by to there. How much do we have to pay to pay for the bike before you even ride it? So you'll notice there's a cost before the time even starts. So how much do you have to pay before you even start riding? And Vi's store charges $3.50 an hour for a bike. Whose store would you rent if you wanted to ride the bike for 3 hours? So this graph will tell you how much it would cost for 3 hours, which they already got you to figure out here. And then Vi's store, it doesn't sound like it has a starting fee. It's just $3.50 an hour for 3 hours. So that sounds like multiplication to me. When you are finished this assignment and you have marked everything, you can fill out the Google form to show me that you're done, and I'll give you some feedback on your answers to the questions. If you need help, you can let me know in the comments. Remember with your Google form that you need to hit submit when you are finished. And if you would like, you can also mark your assignment as done or turn it in to show me that you have submitted your Google form as well, but I'll still get it if you haven't turned it in. If you need help, as always, please comment on Fresh Grade to let me know, and I can set up an individual or a small group Zoom meeting to give you some help.